All right, let's jump right into this. Welcome to this explainer. Today, we're taking a deep dive straight down to the bare metal. You know, an EC2 instance in AWS looks incredibly simple from the outside, right? You just go to the console, pick a size, click launch, and boom, you've got a server. But underneath that simple click is this fascinating, literally mind-boggling layer of custom silicon and distributed systems. Today, we're unpacking the AWS Nitro System. We're going to explore the physical hardware fortress that completely secures and isolates your cloud workloads from the outside world.
But first, let me ask you something that might just totally shatter your assumptions about how the cloud works. When you spin up an instance, is your local NVMe cloud disk actually local? Like, when you see that ultra-fast disk attached to your instance, you probably assume it's sitting right there on the exact same motherboard, right? Well, it's not. That local disk is actually a brilliant software-defined illusion. It's a masterful trick of hardware that exposes a device over a PCIe bus, while the actual heavy lifting happens entirely somewhere else. This is the central mystery of how modern EC2 truly works. And to understand how we got here, we kind of have to look back at the way things used to be.
So here's our roadmap for this explainer. We'll start with the historical flaws of the shared CPU problem, then cover the Nitro hardware shift, see how Nitro cards offload I/O, examine Silicon Trust via the security chip, and wrap up with advanced hardware isolation.
Okay, part 1, the shared CPU problem. To understand the massive bottleneck AWS had to solve, we need to look at this thing called DOM0 or Domain 0. Up until around 2017, EC2 ran on a virtualization platform called Xene, and in this setup, there was this privileged management partition, basically just a stripped-down Linux virtual machine that sat directly next to your customer instance on the exact same physical CPU. This DOM0 partition had to handle literally all the networking and storage I/O in software. And yeah, it worked, but sitting right there next to your customer data on the same silicon, that created a pretty massive performance tax.
The core issue here is all about shared resources. Think of it like a noisy roommate situation. With that old DOM0 architecture, you've got this complex piece of management software handling all the I/O, consuming vital CPU cycles right next to your actual workloads. It's eating up cycles that should be powering your applications, and worse, it creates a much larger attack surface sitting right next to your sensitive data. The ideal state, obviously, is a dedicated CPU with zero performance tax, where your workload is completely and physically isolated. But to get to that ideal state, AWS realized they couldn't just write better software. They had to actually invent entirely new hardware.
Which brings us to part 2, the Nitro hardware shift.
This foundational hardware shift kicked off with the C5 instances back in 2017. And I absolutely love this quote from the source material. It says this was about turning a monolithic virtualization system into a microservices architecture. I mean, that really hits the nail on the head. That is the core philosophy of Nitro. Instead of having one giant software hypervisor trying to do absolutely everything, managing memory, routing network packets, processing storage, AWS decided to break that monolith apart. They decomposed it piece by piece and offloaded those responsibilities to dedicated, purpose-built hardware.
So what's actually in the box now? The Nitro system basically boils down to 3 primary physical components: purpose-built Nitro cards, the Nitro security chip, and this incredibly lightweight Nitro hypervisor. By stripping everything else out and offloading it to hardware, this minimal hypervisor can focus solely on allocating CPU and memory. Its tiny code base practically eliminates the attack surface on the main CPU, which instantly isolates your data from those external management layers. But to really grasp how Nitro fundamentally isolates your instance data, we need to zoom in on the other 2 hardware components, starting with the cards.
Let's get into part 3, Nitro cards and offloading I/O. This is the first major wall of our hardware fortress. These Nitro cards aren't just your standard dumb network adapters. They are literally tiny independent computers designed by AWS's custom chip team over at Annapurna Labs. These little computers live on the PCIe bus of the host motherboard, completely and physically separate from the CPU that your instance runs on. Each card runs its own firmware and acts as a completely independent service processor. You've got distinct cards for VPC networking, for EBS storage, and for local instance storage. And this right here is exactly how instance data gets so intensely isolated. By physically moving the processing of your network packets and storage blocks completely off the main CPU and onto these peripheral cards, there is absolutely zero intersection between the hypervisor managing your data and the systems actually routing it.
Going back to that hook from the beginning, there is a massive difference between what you perceive and what's actually happening under the hood. You perceive a local NVMe disk, but the actual execution, those resources are software-defined devices being exposed over the PCIe bus by remote Nitro cards. Because the card is doing all the heavy lifting elsewhere and delivering practically all of the host's main resources straight to the instances, you get much higher speed networking and lower latency storage. All of that while maintaining perfect physical data isolation. It's seriously a win-win.
Moving on to part 4, the security chip and silicon trust. Okay, so if the Nitro cards isolate data by offloading the work, our next component is the ultimate enforcement mechanism. AWS constantly claims that no admin has access to your instance. Now you might be wondering, is that just an empty corporate promise? Nope. This isn't just some policy written in an employee handbook. It is mathematically and physically enforced by custom silicon. And as we all know, in the world of cloud security, mathematical guarantees will always beat policy promises. Let's see exactly how they pull this off. So how does this chip physically isolate your data? This security chip is quite literally soldered directly onto the motherboard to act as a hardware root of trust. Its main gig is enabling a flawlessly secure boot process. Before absolutely anything else is allowed to happen on that physical server box, this chip steps in and checks exactly what is allowed to boot and run. It gives you this incredible defense-in-depth protection against any unauthorized firmware modification. Think about it. If a bad actor, or honestly even a compromised internal AWS system, somehow tried to alter the firmware to peek your instance data, the security chip physically blocks the system from operating. It completely, totally seals the underlying host away from tampering.
Finally, Part 5, Advanced Hardware Isolation.
See, Nitro doesn't just isolate data from the outside world. It isolates it from the top down, and even from the inside out. One of the absolute most critical, load-bearing design decisions in this whole system is the Nitro controller. This specific Nitro card acts as a hard architectural wall. Think of it as the exclusive, highly restricted gateway between the physical machine your instance runs on, the data plane, and the software that tells your instance what to do, the EC2, EBS, and VPC control planes. There are no other backdoors. None. By forcing every single management command through this one secure, hardware-enforced bottleneck, AWS ensures that administrative operations can literally never bleed over into your private instance data.
And it gets cooler. AWS took this exact same hardware isolation technology that separates you from your neighbors, and they pointed it inward. This is where we get Nitro enclaves. These allow you to basically carve out a super isolated virtual machine right from your own parent instance. These enclaves have zero persistent storage, no external networking, and absolutely no interactive access. What does that mean for you? Well, if you're processing highly sensitive stuff like cryptographic keys or private medical records, you drop it in an enclave. Even if someone has full root access on the parent instance, they cannot reach inside and see the data being processed in that enclave. It is pretty much the ultimate level of instance data isolation. And honestly, the perks just keep coming. Because AWS decomposed the hypervisor into actual silicon, it unlocks some really fascinating features. For one, Nitro intentionally exposes the real CPU topology, like your L3 cache layout, straight to the instance. This is a deliberate transparency choice, so you can literally measure your own noisy neighbor exposure, instead of just having to blindly trust AWS. Plus, this exact architecture is the reason bare metal instances even exist today. Because DOM 0 is completely gone and I/O is handled on the cards, the hypervisor is now entirely optional. Oh, and you also get Nitro TPM for free. That's a virtual hardware security module conforming to the TPM 2.0 spec, which lets your instances generate and store cryptographic keys that not even AWS can access.
Let's look at how this builds into just pure operational brilliance. Think about patching for a second. In the old days, patching a hypervisor meant you had to restart the instance. But actually, scratch that. With Nitro, check out this zero downtime update process. Because the Nitro cards are their own independent tiny computers, AWS can just target a specific card, deliver a cryptographically signed package, and live update the firmware on that specific card, completely independently of the main motherboard. Your running workload, it continues completely uninterrupted. Security controls are never relaxed during the update, and the whole thing is totally invisible to you. It's magic.
So, bringing it all together, what's the big takeaway from all of this? If you contrast legacy virtualization against the Nitro system, it's night and day. The legacy way relied heavily on policy promises and giant monolithic software partitions that had to share your CPU. The Nitro system flips the script. It gives you near bare metal performance with rock-solid mathematical security guarantees, all enforced directly by custom silicon. By breaking the hypervisor apart and fiercely isolating your instance data at the hardware level, using those purpose-built cards and a soldered root of trust, AWS essentially created a fundamentally new paradigm for cloud computing.
Which leaves us with a pretty massive question to chew on. We've explored the anatomy of this entire hardware fortress. We've seen how Nitro cards separate your data processing from network routing, and how the security chip locks down the host from the ground up to keep your data perfectly isolated. So, with custom silicon hardware mathematically enforcing your security and completely eliminating those old performance taxes, what could you build inside your own highly secure Nitro enclave? I really hope this deep dive sparked your curiosity to go find out. Thanks so much for joining me on this explainer, and keep exploring.